Welcome to this video covering section 9.5. This is the third and final video in this series of videos. In this video I will cover how to maximize the volume of a cylinder for a given surface area. In the handouts for sections 9.5 and 9.6, you are asked to determine an expression for the height of a cylinder in terms of the cylinder's radius. You are reminded that the surface area formula for a cylinder is surface area equals 2 times pi r squared plus 2 times pi r h. To rearrange the formula, we can use the basic principles of algebra. We are attempting to isolate the variable h in this case. In the surface formula, you can see that 2 pi r is being added to 2 pi r h. 2 pi r squared is being added to 2 pi r h. So, in order to get rid of 2 pi r squared, we must subtract it from both sides. So here you can see I've subtracted 2 pi r squared from both sides. On the left side you can see surface area minus 2 pi r squared equals 2 pi r squared minus 2 pi r squared plus 2 pi r h. The 2 pi r squares on the right hand side are cancelled out because 2 pi r squared minus 2 pi r squared is going to give us 0. So we can cross those out. And then what we are left with is surface area minus 2 pi r squared equals 2 pi r h. In the equation we have now, we can see that h is being multiplied by 2 pi r. Therefore, to isolate h, we must divide both sides by 2 pi r. So here you can see I've divided both sides by 2 pi r. And these two 2 pi r's are cancelled out. So on the right side we are left with just h. And on the left side we have the formula surface area minus 2 pi r squared divided by 2 pi r equals h. Or if we rearrange it so the variable that we're trying to solve is on the left hand side, it's h equals surface area minus 2 pi r squared divided by 2 pi r. With our cylinder formula now rearranged to express the height in terms of the radius, we can complete the height column of the chart in the handout. So that's this column right here. To find the height, you substitute the given surface area for SA and the radius from the radius column in for r. So to find the height for cylinder 1, your equation should look like this. I have put brackets around the expression on the in the numerator just so you can understand that that part should be solved first before you divide by the denominator. When you solve the equation, it should look like this. And the answer you'll get for h is 58.68. And that's what you would put in the height column for cylinder number 1. So I'll do that here. Hopefully it's not too messy. 58.68. Okay? It ended up being very messy, but forgive me. Okay, so my height is 58.68. To complete the volume column of the chart, you must substitute the values from the radius and height columns into the volume formula for a cylinder, which is V equals pi r squared times h. So your equation should be, and when solved, should be 184.34866, which you can round to 184.35. So 184.35 is your answer for the volume of cylinder number 1. So again, I'm going to try to write this in here, and it would be 184.35. With the instructions that I have just given for cylinder 1, you should be able to complete the rest of the chart. Please take the time to complete the chart on your own before you continue watching the video, as knowing how to calculate the height of a cylinder based on its surface area and radius will be necessary to complete the rest of the handout and assigned textbook work. When you have completed the chart, you should notice that according to the chart, the cylinder with the greatest volume has a radius of 4 and a height of 10.92, and you can see that here, where the volume is highest is 548.89. Unfortunately, this is not entirely true, because we were limited by the fact that we were only using whole numbers for the radius. In fact, the dimensions which provide the maximum volume for a cylinder for a given surface area of 375 meters squared are a radius of 4.46 centimeters and a height of 8.9 centimeters, which would give us a volume of about 557 centimeters cubed. This brings us to an important geometric fact. For a given surface area, the cylinder with the maximum volume has a height that is equal to its diameter, or, in other words, the height is twice its radius. So if 4.6 centimeters is the radius of the cylinder with the maximum volume for the chart, that means that its diameter is 8.92, which is equal to its height. Again, while making the chart is useful for seeing the relationship between a cylinder's radius, height, and its volume, it is an inefficient method for finding the cylinder with the maximum volume for a given surface area. Since we know that the height of the cylinder with the maximum volume for a given surface area is equal to twice its radius, we can substitute 2r for h in the surface area formula, like so. When we do this, we end up with the expression 6 pi r squared, and we can use the equation surface area equals 6 pi r squared to find the radius of the cylinder with the maximum volume when given a surface area. Let's use the given surface area for the cylinder in the chart. The first thing you do is write the formula surface area equals 6 pi r squared. Next, we substitute the given surface area into the formula. We now have the equation 375 equals 6 pi r squared. We're trying to isolate r, we're trying to find the radius, and we can see that 6 pi is multiplied by r squared. So to get rid of the 6 pi from the right-hand side, we need to divide both sides by 6 pi. When I divide both sides by 6 pi, I end up with, on my right-hand side, just r squared, as the 6 pi's are cancelled out, or they become 1, and so I no longer need to write them. On the left side, I'm left with 375 over 6 pi. Now I'm trying to isolate r. I'm trying to find the radius. Now to do so, I'm going to have to square root both sides. Because r is being squared, I square root to get rid of the square. And because I do it to the right side, I have to do it to the left side. When I square root both sides of the equation, I find that the radius is 4.46. A cautionary note here, when you're using the TI-84, be sure to put brackets around the 6 pi when you are square rooting 375 over 6 pi. Now that I have the cylinder's radius, I need to multiply the radius by 2 to find the cylinder's height. When I multiply the radius by 2, I find that the cylinder's height is 8.92 centimeters. Next, I need to substitute the values for the radius and the height into the volume formula for the cylinder. When I substitute in those values, I get the volume as 557 centimeters cubed. That volume is the maximum volume I can have for a cylinder with the given surface area of 375 centimeters squared. Just a quick recap. For a given surface area, the cylinder with the maximum volume has a height that is equal to its diameter. That is, the height is going to be equal to twice its radius. To find the maximum volume of a cylinder for a given surface area, you should 1. Write the formula surface area equals 6 pi r squared. 2. Substitute the given surface area. 3. Divide both sides by 6 pi. 4. Square root both sides of the equation to find the cylinder's radius. 5. Multiply the radius by 2 to find the cylinder's height. And 6. Substitute the values for the radius and the height into the volume formula for a cylinder.